Hi everyone. Today we are going to be talking about trigonometry and in particular similar triangles. Go ahead, grab a piece of paper and a pencil and let's get started. So we're going to be talking about triangle ABC and triangle DEF. We need to first figure out what does that little symbol mean that's between triangle ABC and DEF. It's actually called a tilde and it stands for similar. So this statement says that triangle ABC is similar to triangle DEF. So the first thing that we're going to do is we're going to highlight corresponding side lengths that are similar. So I'm going to get my highlighter tool out, and length DE on the big triangle corresponds with AC from the small triangle. And if I look at BC, that one corresponds with EF. And last but not least, AB corresponds with side length DE. One thing to note when we are labeling these corresponding side lengths, order does matter. So let's go ahead and write that down. So AC corresponds with DF, BC corresponds with EF, and AB corresponds with DE. The next thing we can look at for similar triangles are their angles. So angle A corresponds with angle D, angle C corresponds with angle F, and angle B corresponds with angle E. We could also write our angles with three-letter notation, and the angle that we're referring to would be in the middle. So for example, I could say that angle BAC is equal to angle EDF. And again, the angle that we're looking at is the angle that's in the middle, the letter that's in the middle. So the A and the D correspond. So I could do that for all three of the angles. So angle ACB is equal to angle DFE. And the angle ABC is equal to angle DEF. So again, there are two ways to show that the angles are corresponding. Okay, let's go ahead and take a look at our next slide. Okay, so we're going to actually go ahead and measure the angles this time. So go ahead and grab your protractor and let's get started. We're going to look at the measure of angle A. So if I take my protractor and rotate it and drag it right up to the corner, angle A is 20 degrees. So in the previous slide, we said that angle A and angle D were corresponding. So let's go ahead and check to see if angle D also is equal to 20 degrees. Okay, so once I get my protractor all lined up, I can see that angle D is also equal to 20 degrees. Okay, let's go ahead and check BE and CF. Okay, so for angle B and E, I was able to measure 119 degrees. So go ahead and record your answer. If you're off by a degree or two, that's fine. Try to get as close as... And angle C was 41 degrees. We could verify our numbers as well because we know that the interior sum of the angles of a triangle adds up to 180 degrees. So if I add 20 plus 119 and 41, we get 180 degrees. The next thing we're going to do is we're going to get a ruler and we're going to measure each of the side lengths. Go ahead and grab your ruler and let's start with AB and DE. Okay, once I have my ruler lined up, I can see that AC is 47 millimeters or 4.7 centimeters. Okay, go ahead and measure the other side lengths, please. Okay, once I've measured the other side lengths, I had AB was 47 millimeters, AC was 63 millimeters, and BC was 25 millimeters. Again, if yours is off by a millimeter in either direction, that's fine. DE was 83 millimeters, DF was 110 millimeters, and EF was 44 millimeters. Next, we're going to look at the ratios of the sides. So we're going to take our measure from DE and AB and write them as a fraction. We're going to look at the answer once we divide those two numbers. So I have 83 divided by 47, and that is equal to 1.7. Okay, let's take a look at our ratio for DF over AC. So I have 110 over 63, which is 1.7. And let's go ahead and take a look at our last ratio for EF over BC. Okay, so we have 44 over 25, and that is equal to 1.7. So when I look at those three ratios, I can see that they are all equal, 1.7, 1.7, and 1.7. So that means the ratios of the corresponding side lengths are equal. So for similar triangles, the ratios represent the scale factor, and you may see this represented with the letter K. So the scale factor tells us how many times larger or bigger the large triangle is compared to the small triangle. You can find the lengths of corresponding sides in similar triangles by multiplying or dividing known side lengths by this scale factor. So there are two rules for similarity. Number one, corresponding angles are equal. The second rule for similarity is ratios of corresponding side lengths are equal. In order to prove that two triangles are similar, there are three possible conditions. Side-side-side similarity, or SSS similarity, side-angle-side similarity, SAS similarity, or angle-angle similarity. For the last one, we only have to show that two angles are equal because then by default the third ones have to be equal. Okay, so again, side-side-side similarity, side-angle-side similarity, or angle-angle similarity. Okay, let's take a look at this example here. So we are given that triangle ABC is similar to triangle PQR. So our goal for part A is to find the measure of angle B, angle C, and angle P. So if we know that the two triangles are similar, that means we know that corresponding angles are equal. So we need to figure out, well, which angle is corresponding with B, A, and C from the other triangle. So the first thing I'm going to do is I'm going to get my highlighter and I'm going to highlight the corresponding side lengths because that's easier to kind of see which things correspond with what. So I'll start by looking for the longest side length on both triangles, and I'll highlight that in blue. Next, I'll look for the second longest length, and I'll highlight that in the other color. pink. And last but not least, the smallest side length, I'll highlight in yellow. You can use whatever colors you like. Okay, so angle B, that's where the pink meets the blue. So that's angle Q. B and Q are corresponding angles. So that means angle B has to be the same measure as angle Q. So in this case, if you look closely, angle Q is equal to 26 degrees. So angle B has to equal 26 degrees. Okay, next let's look at angle C. So that's where the blue and the yellow meet on both triangles. So C and R correspond with one another. So angle R is 55, so that means angle C also is 55. And last but not least, angle P. Angle P is where the yellow meets the pink, and on the other triangle, A and P are corresponding, so angle A is 99 degrees, so that means angle P is also 99 degrees. Okay, let's see if we can find the missing side length now. So we're going to find the length of side X and the length of side Y. Okay, so to find the lengths, we need to look at the ratios. So we need to find which two side lengths have both measures given. So if I look at the pink highlight, so AB and PQ on my two triangles, those are the only two side lengths where I'm given both measures in the big triangle and the little triangle. So that's where we're going to get our scale factor, or the K value. So I'm going to set my ratio, my K, equal to 9 divided by 6. I could use 6 divided by 9, it really doesn't matter as long as you're consistent. I'm going to choose big triangle divided by little triangle. So my scale factor here is 1.5. So what I'm going to do is I'm going to next figure out the value of X. Okay, so in order to find X, I'm going to take the corresponding side length 12, and I'm going to divide that by my scale factor. So X is equal to 12 divided by K, so K is my scale factor. So 12 divided by 1.5 is 8. And for good communication, 8 centimeters. Okay, next we're going to look for the Y value. So same idea, Y corresponds with side length 3 on the other triangle, on the smaller triangle. So Y is going to be bigger than 3. So this time I'm going to multiply the side length 3 by my scale factor. So 3 times 1.5 is equal to 4.5. Another way that you could do this is by setting up a ratio, and I'll quickly show you how to do that. Okay, so what we could do is we could also set up our ratios, and we could write that as 9/6 equals 12 over x is equal to y over 3. So what we're going to do is we're going to solve for x and for y. So I could set up 12 over x is equal to 9/6, and then y over 3 is equal to 9/6, and solve for each variable x and y. Let's go ahead and do that. So I could multiply both sides by x and 6, cross multiply to get them out of the denominator. So 9x is equal to 12 times 6 is 72. Divide both sides by 9. So x is equal to 8. And I could do the same thing to find y. So 9/6 is equal to y over 3. So this time the y is not in the denominator, so I can just multiply by 3. So since y is in the numerator, I can multiply both sides by 3. So 9 times 3 is 27. So 27 divided by 6 is 4.5. So whichever method you like, please use that method. So x is equal to 8 and y is equal to 4.5. The next part, we're going to figure out whether the following triangles are similar, why or why not. So the only thing we're given here is the interior angles of 2 of the angles on each of the triangles. So first things first is I'm going to see what the missing angle in each is, because I know the interior angles adds to 180. So I'm going to take 180 for the first triangle ABC and subtract 82 and 28 from 180 and see what angle A is. Go ahead and do that. So angle A is equal to 70 degrees. So let's check to see what the measure of angle P is in the second triangle. So we're going to take 180 minus 65 minus 28 and see what the value of P is. Okay, so I can see angle P is 87 degrees, and because the 3 angles inside of the triangles are not all the same, so I do have a 28 in both triangles, but the other angles are not equal. So no, these triangles are not similar because corresponding angles are not equal. Again, so no, these triangles are not similar because corresponding angles are not equal. Next, we're going to look at the following triangles and determine whether they are similar or not. So this time we're given side lengths. So that means we have to use ratios to determine whether they are similar or not. So I'm going to go ahead and get my highlighter out, and I'm going to highlight what I think is the longest side on both triangles. So 8 and 8, that's the longest measure. The next longest side, 9 and 6. And then last but not least, 8 and 4.5. So I'm going to look at all of those ratios and see if they match. So 12 divided by 8 is 1.5. 9 divided by 6 is 1.5. 8 divided by 4.5 is 1.7 repeat. So in order for these triangles to be similar, all 3 ratios must be equal. So because that third ratio is not equal to 1.5, these triangles are not similar. So let's go ahead and make our conclusion. The triangles are not similar because the ratios are not equal. If I give you triangle ABC is similar to triangle RST, can we find the missing values? So that means all angles and all side lengths. So go ahead, get your highlighter out and highlight corresponding side lengths. So because I told you that they were similar, we know a few things. So we know that angle A and angle R correspond, or are equal rather. So that means angle A has to equal 21. So next we can look at angle S and angle B. So they correspond. So that means angle S has to equal 118 degrees. And last but not least, angle C and angle T correspond. So angle T has to equal 41 degrees. So we're almost done. So now we need to look at all of the missing side lengths. So we're going to look at side length CB, and I'm going to label that X. And we're also going to look for side length RT, and I'll call that Y. So let's go ahead and find the values of X and Y using our ratios. So K is equal to 16 over 10. So K is equal to 1.6. So let's go ahead and look for X. So X corresponds with side length 5.3, but X is in the smaller triangle, so we're going to divide 5.3 by 1.6. So X is equal to 3.3125. Okay, next we're going to look for side length Y. So Y is in the larger triangle, and Y corresponds with side length that is 12 degrees of AC. So we're going to take 12 and multiply it by our scale factor K, which is 1.6. So 12 times 1.6 is 19.2. And for good communication, we should add our units, so centimeters, and for X, it's also centimeters. So now we've found all of the missing angles and all of the missing side lengths. Okay, last question. We're going to prove that triangle ABC is similar to triangle DEF. So we're given ratios, however, we're missing X and Y. So I can't use ratios of side lengths because I would need all three ratios to be given. So next we're going to look at if we're given angles. So I'm not given angle measures, however, I am given symbols that indicate that angles are equal. So angle A from the small triangle is equal to angle D from the larger triangle. And that was given to me with symbols. And if I look at angle B and angle E, they have the same symbol, so they are equal. So because we have two angles that are equal, by default the third angles have to be equal because of the angle sum of a triangle theorem, which adds to 180 degrees. But based on my similarity rules, remember I only need angle-angle similarity. So let's go ahead and make our conclusion. So our conclusion is, since we have angle-angle similarity, triangle ABC is in fact similar to triangle DEF. So therefore triangle ABC is similar to triangle DEF because of angle-angle similarity. And that's it. So we've proven that the triangles are similar. Now that we've proven the triangles are similar, we could go and figure out the lengths of side X and Y. I think we'll save that for another day. Take care, everyone. Bye-bye.